In this video, we're going to talk about client-server architecture. Let's say you have 4 computers, A, B, C, and D, and you have another computer called X. You want to make this X computer a place where all the rest of the computers can keep their files, a centralized place where all the files can be kept, at the same time be downloaded. Then you have to install a software called an FTP server. Once you install that software, this PCX is no longer a PC. It's called a server because now it is ready for other computers to download files or upload files. And on the other hand, these computers in here need to have a software called an FTP client. It's a client software, basically a graphical user interface with which a user can actually establish connection with the server by entering the credentials, whatever is the username and password. And once that credentials are authenticated, he can upload the files or download the files. So here the server is this computer and the client is the software that the user has installed to be able to interact with that server. Now let's see how a website or a web application works on the similar lines. Again, let's say that you have a computer called X, and in that you created a file called abcd.html. Now you want this file to be accessible to rest of the world. What are you going to do? You will have to make this PC a server. So you need to install a server called a web server like Apache. And once you do so, you need to keep this file in a certain folder. Once you do that, the file abcd.html is now accessible to rest of the world. Now me, from my computer, I'll install a client software to be able to access that file, and that client software is nothing but a browser. A browser is something that is able to understand a language called HTML. We'll definitely explore more on these in coming chapters anyway. So let's say from the browser I wanted to access that file. For that I'm going to enter the URL. The URL is going to look something like this. So the first part of this URL constitute, by the way, what is a URL? URL stands for Uniform Resource Locator. And the resource that you wanted to locate in the web is its abcd.html that we have in here. So let's move on. The first part is the protocol. What protocol are we using to communicate with the server? In this case, it's HTTP. This could be many things. This could be HTTPS as well. We'll explore more on that at later chapters. But what does HTTP stand for? HTTP stands for Hypertext Transfer Protocol. It's a protocol that we use to send the hypertext. Now what is hypertext? Hypertext is a language used by both the client and the server to communicate each other using Hypertext Transfer Protocol. And similarly, the server is going to respond back with hypertext using this protocol. Now the second part of it is the website name. Although you're entering the website name, internally browser will replace it with IP address. Browser is going to achieve that by sending a request to a server called DNS, domain name server. The DNS server will have all the records of the domain name and their associated IP address. This server in here does not have a domain name associated. Just as any other computer in this world, it does have some kind of an IP address. And that IP address will be stored in the DNS server. And since we cannot remember the IP address and type in here, we can just simply type the domain name and browser will take care of identifying the IP address to send your request. Now the third part of it is the port number. What is a port? Let's get into details. Let's say that you have this server where you install the web server, but you may not be having this single application. You may be having even more applications. For example, you may have an FTP server, a database management server, or a Skype, and they all wanted to communicate with outside world. So for that purpose, let's say that you have only one single physical port where you connect the LAN cable, and all these applications are going to listen to this port. waiting for incoming traffic and to see if the incoming message belongs to them or not. Now you sent a request from the client without specifying the port number. The request would come in here, but where shall the request go? That's where ports will come into picture. Although we have only one physical port in here, there would be around 65,535 TCP ports and 65,535 UDP ports, and all these are all logical ports, they're not physical ports. So that each one of these applications will listen to a particular logical port. When some incoming request comes, the request must constitute the port number so that the necessary application can absorb it. You can think of server as a hotel, and all these ports are like hotel rooms, and in each room there is one application running. Hope that makes sense. So when we say port 8080, that belongs to a web server. And out of these 65,000 plus ports, the first 1023 ports are reserved. For example, port 80 is reserved for HTTP traffic, like we have now. Now let's go back. Now you might ask me, whenever you enter a URL, you never specified this port. You don't have to. When the server figures out that it's a hypertext transfer protocol, by default, the traffic will be diverted to port 80, where the web server will be listening to. And lastly, you will specify the path of the file. Once you send this entire request from the browser to the server will send the response, and the response would constitute the HTML file in the form of packets. On the receiving end, the packets will again be merged, and obviously we'll be using TCP protocol here, and will be rendered in the browser. And that's how it works. Hope that makes sense, and I'll see you in my next video where we talk about open system interconnection layers. And that would be our final video on the theory part of this chapter. See you soon.